solution is, for all the window glass, we have a manual operation of pulling up the glass is provided now as a protection. This is what the current state. So the next step in the CRISP DM is, again, under the business understanding, we have a factor called defining the success. So here, my expected impact is, so I need to decrease the exposure to air pollution while traveling in a car. So in terms of outcome and output metrics, the outcome is, again, I need to, the reduction of exposure to air pollution while traveling in a passenger car. And my output is mean absolute percentage error of exposure reduction by certain X value. So this is what my metrics, as well as the target is also the same, by a certain percentage of reduction in exposure to air pollution. The constraints is, this safety mechanism will be basically applicable to the AC vehicle only. And because a non-AC vehicle, basically it will be not having any air conditioning system inside. So if this safety mechanism is getting applied here, so my logic is, whenever if the dust or smoke is getting reaching some certain threshold levels, my model will be automatically will be shifting up all the glass windows up. So my car will be covered completely, and the human sitting inside the car will be protected from these environmental pollution factors. So if it is a non-AC vehicle, what will happen is, we cannot sit beyond 5 minutes in a closed area, in a closed car. So it will create a severe problem. So this model basically applies to an air-conditioned vehicle only. Yes, the next one is the factors which I'm mainly dealing here is the dust and smoke. So the dust particle, which is actually which can be measured from the air, and we have also the smoke. And the smoke data is nothing but it could be of anything which is coming out of a car, or if there's something which is a burning of any, burning of any environmental particles, like even a paper or something, which is actually creating smoke. So these things will be measured as a factors. In the data understanding from the CRISP DM process, so the source data is basically it is coming from the sensors. One is dust sensor and second is a smoke sensor, and both are basically will be mounted in the exterior location in the car, in the favorable location where we can actually grab the maximum input. The next one is the data preparation. Yes, again, so here the X variable is our dust and smoke sensor inputs, and the Y variable is nothing but the pollution alert. So this is nothing but my internal variable pollution alert, which will be on or off based on my inputs from the sensor. So these are all the variables from the X side as well as in the Y side. So in the CRISP DM under the modeling, so here I will be considering the logistic regression modeling for predicting the pollution alert signal. So based on inputs from both the sensors, and here I'll be using the OR logic gate for predicting the target variable based on the inputs from the dust and smoke sensor in the vehicle. So the next one is in the evaluation. Yes, this is my logic in the predicting the pollution alert. So when both the sensors are 0 means it's nothing but here what I'm mentioning is the sensor values are, the environmental readings, which is actually the sensor is reading, right? It is under the threshold. So those cases I had considered 0. So my pollution alert will be 0 always. When any one of the sensors getting 1 means my environmental pollution factors reaches a certain threshold in categories like dust or smoke. So my pollution alert will be on in either of the sensor, or both the sensors are getting 1, my pollution alert will be also 1. So this is what my logic behind in predicting the pollution alert. So when my pollution alert is on, so my power windows of all side doors will be closed. My car will be completely covered, and the AC also will be turned on. If it is not turned earlier, when the AC is not turned on earlier, it will be turned on when this logic is getting applied in the vehicle. So the next one is the validation plan. Yes, the hypothesis, the pollution alert signal condition should be considered. So here the possible features we need to consider, which are all actually contributing to the air pollution or health issues, which is actually affecting the human being. So we need to create a plan which is actually the possible features which we should consider as a important thing while predicting the output. So while testing the hypothesis, we need to find which are all the possible features which is actually contributing to the air pollution from the environment, and we need to do the analyzing the learning part. It is nothing but we need to find the maximum or possible valid features which is actually contributing to the prediction. So this is what the validation plan. So we need to go through the series of steps. Finally, we need to define the features which is actually contributing to this air pollution. So this is my validation plan. The next one is my machine learning system design. So here I will be considering the edge system because my sensor data will be collected at the real time and it will be processed in the vehicle ECU system. And the decision will be made at the real time immediately because I need to take the action immediately. The online learning and online prediction is also considered because any real-time changes in the environment needs to be taken care immediately and the prediction needs to be happen immediately because here the delay, if it is happening, then again it will cause a human health issues. So everything should be the result should be happen immediately. So my edge, online learning and online prediction are considered as a system design. And the last one is risk. So here also there is a possible risk under the category data drift. So like suppose the sensor failures or any damages are happened to the sensors in the real-time environment in the car, so it might cause changes in the input values to the ECU, the vehicle. So, and that also can be mitigated by training the model with the failure ranges values like timeout and invalid ranges also. Even if the sensor fails, there would be some input data to the ECU based on the failure of the sensors also. Even if you're training with those particular values also, the risk can be also mitigated and it can be resolved again by replacing it with the new sensor